learn, build, master.
Hi, here is the today's video's agenda. So the very first we are going to see what is HC-SR04, followed by its working principle, then its applications and resources and upcomings. So let's start with a question. What is HC-SR04? Before that, have you ever wondered how the bats can fly in a complete darkness without bumping onto the trees? Or similarly, how dolphins can navigate underwater so effortlessly? Well, they have their own natural version of sonar technology. In a simpler words, they use some sound waves in order to navigate. So similar to that, we have a sensor on our screen, that is HC-SR04. It's nothing but an ultrasonic sensor, also known as ultrasonic range finder. So if you want to perform any of the functions like a distance measurement, a level measurement, or in order to sense the presence of object, and if you are looking for an accurate, reliable and a cost-effective sensor, so here you can go with an HC-SR04. We'll see the specifications of HC-SR04. When it comes to an operating voltage, it operates on 5 volt DC voltage with a rated current of 15 milliamps, and when it comes to measurement range, it varies from 2 cm to 400 cm. Accuracy boils down to plus minus 3 mm. Now we will see the construction of HC-SR04 ultrasonic sensor. Let's start with the front side of the sensor. The very first thing you notice are these two round components, right? So the left one is the transmitter transducer, which sends out the ultrasonic sound waves at a frequency of 40 kHz. Yeah, which is too high for the human ears to hear. And the right side is the receiver transducer. It's like a sensor ear. It listens for the echo when the sound waves bounce back after hitting an object. And the small rectangular component in the middle of transmitter and receiver, it's a crystal oscillator. Just understand in a way, it's a clock for a sensor, generating a stable frequency signal to ensure that transmitter emits sound waves at exactly 40 kHz. This precision is crucial for accurate distance measurement. So later in the upcoming part of the video where I am explaining the working principle, you will understand in a better way. So how exactly the distance measurement is been calculated within the sensor. Now let's move to the bottom of the sensor where you will find the 4 pins. Each pin has a specific function. So the very first, VCC. This is a power input pin. As I explained in specifications, right, the sensor operates at plus 5 volt DC. So this is the pin where we give the power input to the sensor. That is a plus 5 volt DC voltage. Then comes a trigger pin. So this is the pin where you send a short 10 microsecond pulse from your external microcontroller to start the measurement process. Third pin is the echo output pin. The echo pin outputs a pulse whose width represents the time it took for ultrasonic wave to return. This is a key to calculating the distance. So the fourth pin is the ground pin, which completes the circuit by connecting to your system's ground. So just in simpler words, these pins make super easy to interface your sensor with the microcontroller like Arduino or Raspberry Pi for your particular application. Now let's turn the sensor around. Here are the hidden brains of the operation. This is where all the magic happens. View shown in the video, you can see an alphanumeric labels, right, printed on the board. That is U1, U2, U3, J1. They are nothing but a reference designators. So each reference designator corresponds to a specific components on the PCB, making it easy to identify parts during design, manufacturing and testing or troubleshooting. So coming to our sensor, U is the reference designator for IC. C is the reference designator for capacitor, R is for resistor, and J is for connecting pins. So here are the key components that you will find on the PCB. So at U1 reference designator, there is quad operational amplifier, also known as op-amp. They have used LM324 here. So understand in a way, so when the transmitter transmits the sound waves, it goes and hits to an object and comes back. So whatever the signal received by an ultrasonic receiver, it's a weak signal. So basically this op-amp amplifies the weak signal received by an ultrasonic receiver, making it strong enough for the further processing. In addition to that, it does a signal filtering as well shape the signal as per the requirement. At U2 we have a IC that is RCWL9300B. So basically this IC generates the 40 kHz ultrasonic signal that drives the transmitter, ensuring that our sensor is operating at correct frequency. At U3 we have another IC that is RCWL9200. This chip processes the echo signal received by an ultrasonic receiver, performs all the time of flight calculations. In a working principles section, I will explain you how and which formula is used for this calculation, and it generates the echo output pulse. Then we have the resistors and capacitors. This stabilizes the circuit, filters signal, and help manage the power supply for consistent performance. Then we have a buck strip connectors of 2.5 mm pitch. We have 4 pins, so which actually goes and connects to an external microcontroller. Here we start with the working principle of HC-SR04 Ultrasonic Sensor. Now let's talk about how sensor measures the distance using something called time of flight. Yeah, don't worry, it sounds fancy, but it's actually pretty simple. Here's how it works. Let's assume you have connected your ultrasonic sensor with an external microcontroller, for example Arduino. So when you send 10 microsecond trigger pulse to a trigger pin of sensor, the transmitter sends out the burst of ultrasonic sound waves. Think of shouting hello, but in ultrasonic language. The thing to note here is the sound waves is of 40 kHz. So these sound waves travels through the air until they hit an object like a wall. When they bounce back, the sensor's receiver listens carefully and catches the returning echo. It's like the sensor hears its own shout coming back. And as we know, the returning echo is a weak sound waves. The magic happens in the sensor's brain. Let's call it the processor. It calculates the time it took the sound waves to leave the transmitter, hit the object, and return to the receiver. This time is called time of flight. So as you see the formula on your screen, the distance is equal to time of flight into speed of sound divided by 2. So now why divided by 2? That's because the sound waves travel 2 ways, from the sensor to the object and back to the sensor. So we only want the distance for one way. That's why we divide it by 2. So this calculated value is been processed out of the sensor and send it to an external microcontroller. So this is how the ultrasonic sensor works. Let's see the detailed working principle of HC-SR04 ultrasonic sensor with the help of block diagram which you are seeing on your screen. So as we discussed in the last section, let's assume that our sensor is connected to an external microcontroller, example Arduino. So first we have given a plus 5 volt of power input to an sensor, and there is a ground connection between microcontroller and sensor. When we input the 10 microsecond pulse signal through a trigger pin, so that's a trigger input, it goes to an IC that is RCWL9300B. So this IC and crystal oscillator performs their individual function and generates the signal. So now generated 40 kHz of ultrasonic signal is sent to an ultrasonic transmitter. So as ultrasonic transmitter, it's a transducer. It converts it into the sound waves and throws towards an object. So this ultrasonic sound waves goes and hits to an object and gets reflected to an ultrasonic receiver. As ultrasonic receiver is also a transducer, it converts the reflected weak sound waves into an weak electrical signals. So which is further processed by LM324 operational amplifier, where it amplifies the signal, filter out the signal and shape it as per the requirement. So this output signal is sent to another IC, that is RCWL9200, where actual processing and calculation, that is time of flight calculation, happens. Then output digital pulse, which is proportional to a measured distance, it's sent out to an external microcontroller through a echo output pin. So let's see the applications of ultrasonic sensors. The ultrasonic sensor is a true multitasker. In robotics, it is used for obstacle avoidance and navigation. So it's basically helps robots to steer very clearly without any trouble. In automotive systems, it's brain behind the parking sensor, making parking a breeze. Also, it can be used for an object detection application. For an example, a liquid dispenser, what you can see on your screen. There are countless applications as well. You as a innovators, you can use this ultrasonic sensor in many DIY projects like a smart dustbin, automated door openers, pet feeders, etc. There are countless applications of ultrasonic sensor. So here are we in the last part of our video, that is resources and upcomings. So in resources, we have a very high quality images of HC-SR04 ultrasonic rangefinder, what we have discussed in detail in this video. If you want to use these images in any of your project reports or anywhere, you can use that. Then in another resource, we are providing in detailed explained Arduino codes for you guys for distance measurement, level measurement and presence of object. Just try few of them. For resources, please do check out the description. We have provided the drive link where you can find all the resources. And in an upcoming section, we are thinking to create one detailed video on hands-on DIY project using this ultrasonic rangefinder, that is HC-SR04. So if you want to see any particular DIY project, yeah, please do comment. Thank you for being with us and watching. The Engineering Essentials signing off.